you should already have out the materials that you need. Now, when we're looking at these, we're going to first talk about nitric acid. Anytime I have one single reactant, okay, I am immediately thinking that is decomposition. Okay, decomposition. And as I look at my decomposition reaction, I know that nitric acid, first of all, is HNO3, based on my acid rules. I know that it is heated, so I'm putting a little triangle above. What am I dealing with? What am I decomposing? Decomposition number 5. So this is a decomp number 5. Decomp number 5, which tells me that I have an oxyacid heated to give me a nonmetal oxide and water. I would, yes. Parker's talking about the worksheet he's dealing with. I guess I should be more clear. The worksheet that you have for homework, put the actual number 2 of what type of a reaction. So I'm looking at this right here. I know I got an oxyacid heated. It's going to give me a nonmetal oxide and water. So I know that one of my products is water. Now the problem with this particular one is that I have a monoprotic acid, meaning I only have one hydrogen. So I'm going to need 2 of these particular 2 nitric acids to break down to get a water. When I do that, okay, I believe when you had the video over decomposition, what I did and what I usually do is if I have 2 of these, I think of it like this. Okay? I think of doubling my stuff, and then from that, I subtract water. Well, if I have that and I subtract water, those H's go away, and I have N2O5. So my non-metal oxide that I have left would be, cleaning up my equation, dinitrogen pentoxide. If you have questions, go ahead, raise your hand, chime in. Okay, the second one, calcium oxide is reacted with cold water. Calcium oxide is reacted with cold water. Now, does it matter whether we have cold water or steam? Yes. Yes, it does, because if you look on your activity series, cold water and steam make a difference, okay? Not for this particular one, though, okay? Not for this particular one. We're looking at a combination reaction. Active metal oxide and water. Now, is this active enough? Is this a group 1 or a group 2 metal? Yes, so it is active enough. So, an active metal oxide plus water, I guess I should put, this is a combination number 3. So, an active Metal oxide plus water is going to give me a metal hydroxide. My metal is calcium, so it's going to give me calcium hydroxide. Now all I have to do is balance my chemical equation, and as I'm looking at that, that is already a balanced chemical equation. Our third problem, potassium sulfide reacts with iron 2 nitrate. Potassium sulfide reacts with iron 2 nitrate. Now this is a double replacement reaction with 2 aqueous salts. So this is a double replacement number 1. Double replacement number 1. When I have 2 aqueous salts, I have my rules I need to follow. So the first thing I am going to do is I'm going to swap. I'm going to swap my cations. So I'm going to get KNO3 and iron 2 sulfide. As I do this, I now need to check. I need to check my activity series to see if these will actually work. Now I can't find, here it is. Actually not my activity series, my solubility chart. I'm looking at potassium nitrate is soluble. So potassium nitrate is soluble. Iron 2 sulfide is insoluble. So will this reaction occur? One is aqueous, one is insoluble. Yes, it will occur. Now, people miss this on their double replacement half sheet also. I drew it in when I was grading these. You have to write which one is a down arrow or a solid and which one is aqueous. If you don't do that, you are losing points, folks. If you don't do that, you are losing points. So make sure that you do that. Final thing, am I balanced? No, I am not. But now I am. But now I am. Final one is bromine reacts with sodium chloride. Bromine is a super 7. It is reacting with sodium chloride. This is a single replacement reaction, specifically with a halogen and an aqueous salt. So this is a single replacement. Number 4. Now the thing with this that you have to remember, that this halogen is trying to replace that halogen. So bromine is trying to replace chlorine. Is bromine high enough on the activity series to kick out chlorine? No, it is not. So this is a no reaction. Bromine is not active enough to replace chlorine. Go ahead and take those and pass them this way. I'm collecting those.